Hi, thanks very much for listening to this and for considering this file where I overview one of my favorite activities, favorite features, that is, of Desmos. This is Andy Benzing, and one of my favorite features is this draggable point that's been added. I don't know how long ago now, maybe even a little bit over a year. I find more and more applications of it in terms of putting the students in control and in charge of the sketch applet application that we kind of make here. This is kind of at a warm-up opening day for a calculus class where they understand derivatives. They've actually done some derivatives of functions, linear functions, quadratic functions, lots of polynomials, and we're launching into the derivatives of trigonometric functions. So they have a basis, and one of the things I like about all graphic technologies, Desmos in particular, is that students can kind of extend the base knowledge they have into new material given the right prompts and right scenario, and the draggable point allows us to do that. So up at the top, we've got consider the slope of the tangent line. So the kids know a lot about this blue line, in fact is the tangent line, and they're trying to measure the value of the slope. I just want approximations here as they look at it. Is it positive? Is it negative? And because of the draggable point, when they grab it and drag it, they'll see that this tangent line is dynamic and adjusts based on wherever this point that they drag is. So the prompt asks them to consider, when is the slope of this line 0? When is it negative? When is it positive? When is the slope increasing? And then when does the slope start to decrease again? We're trying to plant a lot of seeds here down the road for the students that they can refer to later on. So they roll it left to right. I have my kids sitting in groups. They're in groups of 4. For an activity like this, I might have one computer for the 2 of them to guarantee that they're talking to someone at the very least. With some of their observations as they roll it left to right. So after I give them some time to kind of play here, it says down here, test your observations. And we've done this a few times now, but in essence the idea is this is a function, right? The value of that slope at that particular x value we can plot on the coordinate plane. And what would that look like right here? Well, it appears as though it's positive. So when I turn on this icon, they can see the value of this orange marker is in fact positive. And as I roll left to right, the slope is actually decreasing in value, and they can see the orange point is in fact decreasing as well until, oh dear, we're here at 0. Which is interesting for the students because they can control this and try to explore, oh, that's interesting, the function itself is at a maximum, but the rate of change of the function is 0. Ask some further questions. What's going to happen as we roll down the mountainside here as the slopes begin to decrease? When would the value of the tangent line be at a minimum? Right? And they're surprised often, I think, to find that it's not at a minimum value of the function, but somewhere in the middle here. And what does that mean? And again, always trying to plant some seeds for down the road. So this is one of my favorite features, the draggable point on Desmos. Pretty easy to construct in the file as well, and it's nice because it puts the kids at the center of the learning as opposed to a slider over here. This is connected and attached nicely right to the function itself. Thanks very much for considering it.